Today we're going to take a look at right triangle trig. Oops. And you guys might remember doing this probably back in geometry. I don't think anybody did it last year, but do you guys remember SOHCAHTOA? So we're going to talk about relationships between different sides of triangles, and we're going to build on the SOHCAHTOA that you have done in the past. So just remembering in the past, this works for right triangles. There's that relationship between sides and angles. So the longest part is your hypotenuse. And I'm going to mark an angle here. Let's say I mark this angle A. The side across from it is the opposite, and the other side is adjacent. So SOHCAHTOA is that relationship. So if I said the sine of angle A, the sine of angle A is the relationship between the opposite and the hypotenuse. If I said the cosine of angle A, that's the relationship between the adjacent and the hypotenuse. And if I said the tangent of angle A, that's the relationship between the opposite and the adjacent. And so those three you've done in the past, but we're adding three more that are called the reciprocal functions. So if I was to say the cosecant of A, that's just the reciprocal of the sine. So it's the hypotenuse over the opposite. If I was to say the secant of A, that is the hypotenuse over the adjacent. And if it was the cotangent of A, that is the adjacent over the opposite. So let's take a look at a couple triangles here. So let's take a look at, and again, this only works for right triangles. And if I was to label this 65, 56, and 33, and if I was to put angle A up here and angle B down here. So if I was to find these 6 trig functions, let's say I was to say the sine of angle A. SOHCAHTOA, so if here is our hypotenuse, is always going to be that side opposite 90. But what's opposite A? So we have to go opposite A. So this is going to be the opposite. And then this would be the adjacent, because opposite is across. So our sine would be 33 over 65. Our cosine of A, adjacent over hypotenuse, 56 over 65. The tangent of A, the opposite over adjacent, 33 over 56. And then you could do those reciprocal ones. So the cosecant of A would be 64 over 33. The secant of A would be 65 over 56. And the cotangent of A would be 56 over 33. Now we have to think about how would this change if I would have said the sine of angle B. So now I'm going from angle B. So across is now the opposite. So opposite B, and the 33 is the adjacent. So if I was to say the sine of B, it would be 56 over 65. The cosine of B, so adjacent B, 33 over 65. And then the tangent of B, opposite over adjacent, 56 over 33. Now where this comes in handy is to find different side lengths and angles. So you can use this to find missing side lengths. So we're going to take a look at two different problems here. So our first one, let's say we have a right triangle, and I put in here that this is 36 degrees. We have x and 13. So what we can do is set up a trig function here. So we know that if I use 36 degrees, this is the hypotenuse, and x is adjacent. So adjacent and hypotenuse is cosine. So the cosine of 36 equals adjacent over hypotenuse. And then how do we just solve for x? We'd say times 13 times 13. So 13 times the cosine of 36 equals x. And then you need a calculator to type this in. So one thing on Desmos is you want to make sure you're in degrees. So if you hit that little wrench key, it automatically is in something called radians. And that's kind of like how we measure temperature in Fahrenheit and Celsius. There's different ways to measure angles. So click on degrees. And now, and again, I forgot the problem. So 13 times, if you hit functions, trig, the cosine of 56, we get 7.3. Oh, it was 36, my bad. So let's go back here and switch that to 36, 10.5. And we could even round it to 10.52. So let's take a look at another one like this. So let's take a look at, we have a right triangle. Maybe up here I say is 42 degrees, 15 and x. And you need to find x. So again, if I know this angle is 42, across from that, so that's the opposite. This is the adjacent. So we have opposite and adjacent, so tangent. So the tangent of 42 equals 15 over x. So let's get rid of our fraction here. So times x times x. So x times the tangent of 42 equals 15. And then to solve for x, we divide by the tan of 42. So we have x equals, and again, hit that wrench key. Yep, we're still in degrees. So 15 divided by the tangent of 42, 16.66. Now we can also use trig functions for finding angles, missing angles. And we're going to use those same trig functions, but similar, we're going to use the inverse trig functions. Where we're going to find side lengths and it'll tell us the angles. So up here, I might have misspoke here, but these are your reciprocal trig functions. So at the beginning, these three over here, these are your reciprocal functions because we flipped those fractions. But now we're going to be talking about your inverse functions. And our inverse functions, you find them on the calculator. They are sine, and we use that inverse symbol, cosine, and our tan inverse. And so problems where you would use these are like if we had a triangle, and let's say you needed to find x degrees, and you were given 11 and 13. So what trig functions are we given here? Well, if this is x, so that's opposite and adjacent. So we would set something up that says, well, the tangent of x, that angle x, equals 11 over 13, opposite over adjacent. So the inverse of 11 over 13 gives us our angle. And you find those, let's check, yep, we're still in degrees. You find those trig functions, you see the tan -1. So we have 40.2 degrees. So let's take a look at one more like this. So let's have another triangle here. Maybe our x is up here, and we have 13 and 17. So again, I look at this across, so that's opposite. Well, this is our hypotenuse. So opposite and hypotenuse is our sine. So the sine of x equals 13 over 17. So we could do that inverse, and that gives us our x. So we can jump back here, functions, trig, inverse. Whoops, that didn't work. 13 over 17, 49.88 degrees.